Hello, my name is Josh McNutt. I head up the data strategy team at Showtime, and I've been in the data science profession for, I think it's 18 years now by way of graduate school in statistics. I've worked in a variety of different industries before joining Showtime in January of 2017 to build out the data strategy team from scratch. And I'm here with Keria Bermudez-Hernandez, my colleague, who will introduce herself.
Hi everyone, my name is Keria. I'm a data scientist in the data strategy team at Showtime. I joined Showtime in November of 2017, and before Showtime, I was doing bioinformatics research in academia. But today I'm really excited to talk to you about what we've been working on for the past year and a half.
Awesome, thanks Keria. So the title of our talk is Data-Driven Transformation, Leveraging Big Data at Showtime with Apache Spark. So over the next 30 minutes or so, Keria and I are going to be talking about the analytics infrastructure that we've been building with our colleague Dan Vatterott at Showtime to really help facilitate the process of ushering in a new era of data-driven management of the Showtime network business, leveraging the data set we have access to now. So virtually everyone in this room is already familiar with Showtime. We're a premium cable network known for our hit shows such as Shameless, Homeland, and my personal favorite, Billions, which is currently in premiere. And if you want to get on your phone and sign up for a free trial now, you could be watching episodes of Billions by the break. And I'm going to keep track of how many people do that because I need to get my quota up. But so we've got all this amazing content, these hit shows, but it was really the reason we're so excited to be here today is in the last few years, it was with the launch of our standalone streaming service that we gained access to what at Showtime has been an unprecedented level of user-level information, a granularity we've never had before as part of our streaming service. And so with the streaming service, we get this awesome thing, this direct relationship with our customer. And with that direct relationship, obviously, we get a lot of data. We get really rich viewing data, so we know what our users are watching, what devices they watch on, what time of day, days of week, et cetera, whether they're binging. But we also know all about their customer journey with great granularity. So we know when our subscribers renew, cancel, resubscribe, how long in total they've been paying subscribers throughout their history, no matter what that customer journey may look like over time. And we also have information about their interaction with our emails and push notifications, who's opening, who's not opening, to look for relationships there when somebody opts out of communications and things like that. So we've got all this information that's curated and standardized, normalized by data engineers on our product team who ingest this information into our data lake in Amazon S3. And basically, it gives us access to billions of records just waiting to be analyzed. And with the arrival of this information, all this data, you can imagine that the expectations grew quite quickly in terms of like, what are we going to get out of this information? And the number of questions exploded in both volume and level of sophistication in terms of like, what are the questions we want to use this information to answer? Just a few examples. What is the lifetime value of a subscriber who signs up to watch Ray Donovan? So obviously this informs things like your acquisition strategy. How much should we be willing to pay, sort of that cost per acquisition, to acquire different types of subscribers based on the content that they're going to be viewing or that they're interested in? How many free trial signups have been generated by another series, Shameless, on our network? How many of those achieved paid subscription? Really getting to a point where we can identify the volume, the growth in both subscriber count and revenue associated with each series and each season of a series. What's the probability a subscriber is going to start watching my favorite show, Billions, for the first time ever in the next 7 days? So really using the information that we're compiling to kind of understand what's that next best series that we should be trying to sort of match a user to, because we think based on their history and what they've viewed that it's going to resonate with them. So as we've had this skyrocketing number of questions, in the early days of this data becoming available, unfortunately, our capacity to answer these questions was lagging behind. The situation was we would have all this really rich data in our data lake, highly granular, et cetera, like I described, and then we've got a lot of research and business analysts around the company. And the reality is that very simple questions, basic questions, could be answered with very solid operational reporting that was in place. But when it got to more complex queries, that's when we needed more custom analyses to be structured, and that took, at times, took weeks or even longer, or we just decided the effort's just too significant to put something together. And the research and business analysts around Showtime, they're not data scientists, and they lacked the data science skills to be interacting directly with the data lake at that point. And so they were, for the most part, out of luck when it came to being self-service in answering their own questions that they needed to inform their business units' priorities. So capacity to answer these questions was lagging behind. The organization was faced with the question, sort of, how do we reduce this gap between the demand for the questions that could be answered with this data and our ability to actually start answering those questions. And it was around this point that there was the formation of the data strategy team that Keria and I are both a part of, along with our colleague Dan Vatterott. And we're a small team of data scientists working to democratize data and analytics at Showtime, to understand and predict subscriber behaviors, and to support data-driven programming and scheduling. So for the first pillar, democratizing data and analytics, so we're taking kind of going from two angles. We're working to bring the data closer to the users, but we're also working to bring the users closer to the data. And so in order to bring the data closer to the users, we're engaged in what I would refer to as sort of an augmenting of our data supply chain. So we're making the data more suitable for analysis, deriving more advanced behavioral features, pre-computing various statistical summaries so that more can be done and very quickly rather than just having all the raw data in the data lake. And so the primary output, not the only, but the primary output in terms of providing that analysis-ready data is what we refer to as our master viewers table. So the master viewers table is our foundational customer data representation. It captures for every distinct user who has ever signed up for our standalone service, thousands of metrics and behaviors. So we know everything that they're watching, everything they did in their free trial, everything they did in paid month one, in their entire lifetime on the platform, the devices they're using, et cetera, et cetera. So there's a lot of decisions to make about how to capture that information and represent it in a table like so. One of the things that we're happy to be tracking there as well that's really important is each user's relationship to each of our series. And more importantly, their relationship to a series at any snapshot in time. So at a particular snapshot in time, I know a user was caught up on Billions, or they were not caught up, but in progress on Homeland. And maybe they had abandoned yet another series. So that kind of information, that rich information of the status of a user at any point in time vis-a-vis the various series, especially with our premiere schedule being what it is, it's really important to know that information when trying to predict who's likelier or not to cancel their service, or what's their status when another season rolls around. How likely are they to resubscribe and come back to us as paying subscribers? So the Master Viewers Table framework, it's really the ideal framework for building training data for machine learning modeling. So all of our machine learning models are informed, the inputs are provided, the features from the Master Viewers Table. Sometimes we add a little bit of logic on top of that for certain custom features per model. So we use it for being that sort of time machine to build the training data and then getting that ground truth of what happened next. But then we're also making the most recent snapshots of this information available to our analysts for reporting, dashboarding, and ad hoc analysis. So that's where we're augmenting the data supply chain, bringing the data closer to the users. And then on the other side, bringing the users closer to the data. In that sense, we're really talking about skills training. So we've established what we refer to as a data strategy bootcamp internal to Showtime. And we're getting these folks learning how to navigate the thousands of features in the master viewers table and other enhanced tables that we make available using Tableau, using SQL. We've got people connected via Databricks customers, so connecting with Databricks notebooks as well. And so by having this sort of two-pronged strategy, we're working to create the conditions to create this chain reaction of curiosity, exploration, analysis, and insight. So really empowering our colleagues to become much more effective and facile with manipulating data, analyzing data, and really magnifying their impact on better decision making around the network. So the second pillar is understanding and predicting subscriber behavior. So here, we're all data scientists on my team, and so we're really trying to understand each of our subscribers intimately. What is their trajectory, their likelihood to cancel or churn, their likelihood to resubscribe, how long are we going to keep them as subscribers, et cetera. How much revenue are we going to derive from them, which is obviously a consequence of how long they're going to stick around. So we use the machine learning models to understand each subscriber's trajectory and in aggregate understand sort of the business trajectory or trajectory of various segments. But predicting behavior is a lot easier than changing behavior, but you need to start have that baseline on a per customer basis, so then you can do your testing and do more of a strict kind of get some causality about, okay, this tactic works for this segment, this tactic works for that segment. So really, this is just the first step, is building these models, but I'll give a brief overview of sort of the different models that we've put into production, some of them so far. We've got our churn propensity model that scores the likelihood that somebody's going to cancel in the next period. We've got our resubscription propensity model, which scores a probability for each subscriber who's currently lapsed that they're going to resubscribe, return as paying subscribers for a particular series that's returning with a season in premiere, like the most recent season of Billions being an example. We put a dollar value, our future customer value, so we estimate the expected revenue contribution for each subscriber over the next 12 months, which is great for informing part of the revenue forecasting challenge in terms of looking at our existing portfolio of subscribers and knowing how much revenue they're going to be responsible for, but also understanding the value of different segments just as a more general use case. And then the series viewership propensity model, that's what I referred to earlier, is really trying to understand like what's that next best series that we should be employing marketing tactics, email, push, dynamic pre-roll, the promotions that we roll when you're trying to watch a movie or something. We have a 15 or 30-second spot. How should we use that spot from a marketing perspective to connect users with the series that we think is going to resonate the most with them? Third pillar is supporting data-driven programming and scheduling. So one of the best ways to inform your programming strategy is to be able to attribute revenue and subscribers to your content, to each series and each season of a series. And so as an example, for Billions, we want to know how many free trial signups were driven, how many of them reached paid status, converted off the free trial, how many resubscribers coming back to us after being lapsed, as well as among people that were already with us, our existing paid base. How does the act of having Billions available and people watching this latest season, how is that reducing churn, and how can we value that as well? And so for the connects, for the people that come and sign up for a free trial and convert or return as paying subscribers, go direct to paid, we estimate a mean lifetime, and so we can get a mean lifetime value, and we get to that subscriber growth, overall impact, the revenue growth, overall impact from a season of one of our shows. And obviously that informs, for any of our shows, renewal decisions, how aggressively we fight to get another season, potentially for a show, as well as scheduling optimization, smoothing out the schedule, the linear premiere schedule throughout the year. One of our more recent initiatives that we've begun work on that's not ready just yet is we're working on a simulation framework to be able to select among several viable scheduling scenarios, because there's a lot of conflicts, there's a lot of constraints, I should say, for when shows are going to be available. But when you've got multiple competing viable options, having a data-driven way of scoring which of these scenarios is likeliest to maximize retention and revenue. And so that's another project that we're working on with the data that we're constructing. So that's all the stuff we've been working on, but I want to kind of, as important to our story is to kind of go back to the beginning, because all that probably wasn't possible if we hadn't made some decisions and some partnerships along the way. So at the very beginning, we were just trying to get our basic infrastructure in place. And so we knew that our data lake was in S3. We knew that we were going to be writing our code base in Python and Spark. I myself, the good news was I was sort of patient zero, the first person on the team. And so I could start developing the first version of our data pipeline to start getting some quick wins and some insights. So the good news is I had some experience with Spark. The bad news is it was kind of on a version 1.3, and I had some, my habits and conventions that I was used to using was a lot of RDD transformations, Lambda functions mapping to pandas logic. And it gets the job done, but one of the exciting things Keria is going to be talking about in the next section is really how we've optimized. We've gotten beyond that sort of initial proof of concept to much more performant approaches to really maximizing the real power of modern Spark. Other thing we needed to account for was our BI tool. Tableau is the licensed BI tool internally, so we need to make sure we could connect to that. And for users at all levels, we wanted to make sure we had the notebook functionality, because there's just so many benefits to that. So we were basically in a situation where we were like, how do we stitch everything together? And we had some challenges. Again, the immediate team is exclusively data scientists, so we were dealing with so many headaches, configuring clusters, dealing with cluster termination errors. Our clusters were slow to launch. We were debugging, bootstrap scripts, et cetera, et cetera. So generally speaking, we reached a place where we were fairly tentative and sometimes intimidated by making too many changes or try to make too many improvements, because just all the additional configuration headaches, which never really went away. So that unfortunately lasted for a fair number of months before we got wise to sort of where we were in the world. And it was around that point that I reached out to Keith Haller at Databricks to learn more about their platform. I'd heard good things, but just wanted to see what it was all about. And before I knew it, we were in a proof of concept. And then shortly thereafter, we were customers, which we've been for about a year and a half now. And so in the new world, at that point, which we've been enjoying for the last year and a half, we're just having the ability to allow Databricks to manage our clusters, eliminating all those configuration headaches. It's meant so much to the productivity of our team. We haven't had to hire a dedicated DevOps engineer just to kind of keep things working. And we're not sophisticated enough to know, like, how would we even know, like, the skill set that we would need for that? It allows us to get by, amazingly, with data scientists that are obviously wanting to focus on data science itself. So I'm going to hand things off to Keria, who's going to talk about the building of the data pipeline that made all that I described possible, as well as a lot of the optimization work.
Thanks, Josh. So our data pipeline starts with our data lake that is generated by data engineers from the product team. We build on top of it a series of Spark jobs, and we create the master viewers table. The master viewers table is then used to train machine learning models. And Josh spoke earlier about different use cases of those machine learning models. On the other hand, the master viewers table can be accessed through Tableau, and research analysts can do queries, reports, and dashboards, and they can share that information across the company. But today I'm going to be focusing on this part here, in the code base that we created, the series of Spark jobs to generate the master viewers table. So a year and a half ago, our pipeline was running really, really slow. It was taking up to 24 hours to complete. So we needed to find solutions to make this runtime make it faster. So that's what I'm going to talk to you about today, about the solutions that we have found to make this pipeline run faster. So among the solutions is the implementation of Apache Airflow to schedule jobs in different clusters. And we made a series of code optimizations, such as replacing RDDs and pandas transformations with PySpark data frame transformations. And also, we're using multi-threading with the features model. So we'll be talking about that too. Before implementing Apache Airflow, we were running jobs sequentially in a single notebook. We realized that we wanted to run them in a concurrent fashion. And while technically you can do that in a single notebook, managing complex dependencies is really hard to do in a single notebook, right? So we needed to find an alternative to this problem. And that's where we use Apache Airflow. With Apache Airflow, we can schedule jobs, and each job can run in a different cluster. And for us, it was great because it had really good integration with Databricks. Also, it would alert us if the data was not available before running the job. So this was a game changer for us at the beginning. So now we'll talk to you about a series of code optimization tactics that we did. But before I do that, I'm going to tell you how we were doing things in the past. So our data was organized in RDDs, so shown here to the left. For each user, we contain all the information in a single RDD. It contained viewership information, subscriber information, and then to get all those features that Josh talked about, then we had this function here, wrapper function, and we mapped this function to the RDD. Inside of it, it contained tons of methods. Some of them had pandas methods. So it was really complicated. However, it got us to working with something, and it was great at the beginning, but it was taking a long time to run. So we needed to find a solution to make this run faster. So one of the things that we changed was instead of having RDDs, having our data in data frames. So now instead of having one user having one RDD, we have multiple records for that user in that data frame. And then we can apply a series of PySpark transformations to that data frame to get that feature. One trick that we used was to chain all these methods using the compose function from the SciTools package. So we chain all these functions, all these transformations, and then we got the same output, but our runtime was way faster. So this was a great improvement. That step that I just explained was repeated multiple times, shown here to the left. We created subtables, and we realized, again, that these tables were not dependent on each other. We can run them concurrently. So we decided to use the features model to do multi-threading, and that's what we did. Finally, in order to reduce the complexity of the tasks for this process, we save the intermediate tables before joining our final table. So I've told you about different levels that we control concurrency. We run different jobs in different clusters using Airflow. We do multi-threading using the features model. And finally, we take advantage of the intrinsic parallelism that exists within a data frame. Overall, this dramatically reduces our runtime. Our pipeline now runs in less than 4 hours. And here to the right, you can see the user interface of Airflow for different jobs of our pipeline. So some of our jobs were taking 10 to 14 hours to complete. And now they're taking less than an hour. So we're a group exclusively of data scientists. We don't have, for our team, data engineers. So this was really exciting for us to get to this runtime. How did we achieve this? We come from academia and from experimenting. So Dan Vader and myself used to do a lot of experiments. So that's how we finally got into this runtime. How did we log the results of our experiments? So we use MLflow. So we tried different things. We logged certain parameters, certain things that we tried, and that's how we got into this runtime. Now I'll tell you another use case of MLflow, and that's to track the quality of our data. There's some instances where we had missing records in our data lake. What happened is that this problem would translate to our pipeline. And it was not until the analyst that they would figure out there's something wrong with our data. They would inform us or the engineers, and then they would fix the problem. This is not an ideal situation, right? We want to catch the problem earlier. And that's why right now we're using MLflow. So with MLflow, we track the quality of our data daily. So we log metrics of our data with MLflow daily. And then we run a series of scripts to determine if those metrics are outside the normal range. If they're outside the normal range, then we get an email alert, and we investigate whether there's a real problem. If there's a real problem, we inform engineers, and they fix the problem. You can see here that we have different levels of logging in our pipeline. So we log metrics after we create the master virus table, and we also log the accuracy of our models. So every week, we retrain models, and we check the accuracy of our model for the past week. And those are the things that we log. If the accuracy is below a certain threshold, then we get an email alert, and we can go check it out. Finally, I'm going to tell you something that we've been experimenting lately, and that's the use of Delta to update tables. So Delta is an engine built on top of Spark. You probably heard about it. So before Delta, we had certain tables that we had to update fields. And without Delta, this process was taking 3 hours. So we had to rewrite the whole table, and it was taking a long time. With Delta, we ingest the same data daily, but we only update those fields that are necessary to update. And that process is taking now approximately 30 minutes. So I've told you today about different tactics in terms of optimization. So we use Apache Airflow, again, to schedule jobs in different clusters. We have done a series of code optimizations, such as using multi-threading. We use MLflow to track the quality of our data. And finally, we're experimenting with Delta to update our tables.
Awesome. Thanks, Keria. So we're just going to leave a few final thoughts. Obviously, the unified platform that we've been building for the last year and a half plus has really allowed us to democratize data and analytics in a phenomenal way around the organization, dramatically reducing the time needed to answer questions. And now the questions get more and more advanced, and so on and so forth as we get smarter and learn more about how our subscribers behave and interact with our content. As Keria pointed out, we continue to engage in ongoing innovation and optimization work, and we're really building towards being able to scale not just to more data that invariably is going to come over time, but also as we work towards that next generation of machine learning models and advanced behavioral features as well. Speaking for the team, we're just really excited to be part of this revolution inside Showtime, getting access to all this rich information, this cultural shift that we're a part of. And we're working every day to weave data and analytics into the fabric of the network. And as you've seen here today, the transformation, data-driven transformation is well underway. So thank you very much. Do we have questions?
Yeah, we have a mic over here and on this side, so you can come up for any questions.
Hi, great presentation, thanks. Do you find the data that's coming from the app and the online subscribers correlates well with the linear and regular subscribers that watch through cable, or have you not gotten there yet?
Generally speaking, they're very different universes of subscribers and users. We've got people that are subscribed and using the app. We tend to see a lot of heavier usage than potentially in a bundled environment or a situation where somebody's got a whole bunch of linear premium cable network channels to choose from. So there's a little bit higher, there's definitely higher usage, more titles per user that we'll see. The viewership reach among the subscriber base tends to be quite high.
Thanks for the great presentation. Can you talk a little bit about the master table and how do you work with it? Because I think we have something similar in our company and it's really, really slow. So I'm thinking about ways to improve.
Yes, I'll take this one. It's basically, we invented our own sort of naming convention that establishes sort of how we understand what somebody did, when they did it. It's all relative to each subscriber's lifetime, their free trial, their last 30 days or whatever at any snapshot in time. But to be honest, ultimately the table itself we make available to our users in Tableau Server predominantly. We've also, since with all the additional bootcamp training that Keria is doing, the more advanced bootcamp training, getting people up and running on Databricks notebooks, people can query it there as well. Performance doesn't seem to be a huge issue currently. We keep, we've got thousands of features, but we could easily have hundreds of thousands of features. So we have to make some choices because you get a combinatorial explosion when you've got all the different potential moments in time or time windows per user, times all the different kind of content categories, and then the different metrics to be tracking. So really, it's a lot smaller than it could be, but over time we may get a little bit more aggressive in scaling it. But with thousands of features, we have to train people how to, learn the naming convention and be able to, the search functionality, even just within Tableau, to find the exact field you're looking for. That search bar is you need it. It's essential to be able to make anything out of thousands of features.
So you mentioned that you use MLflow for data quality checks. So you do that at the golden data, or you are doing much earlier almost at raw data level quality?
Yeah. So we're doing it at the raw, the data lake, which is not necessarily the raw data because we already have it from the data engineers, but it's raw for us. But also we do checks in intermediate steps. So after we create the master variance table, we also log the quality of that data, and also we log the quality of our models. So we have different levels of tracking along the process.
In the second pillar, you're talking about using data to model and predict the subscriber propensity and cancellations and whatnot.
Yep.
Is that, can you talk a little bit about the application of that in your organization and how that meaningfully changed the revenue or the business?
Yeah, I mean, it really comes down to, I'll speak to sort of the churn model specifically. So having the churn model in place allows us to identify our most at-risk subscribers, and then that becomes a pool of a targetable universe for both sort of testing various retention tactics to try to change their ultimate outcome, as well as just to prioritize any retention tactics that are established that are working to focus it on the people that it would potentially have the biggest impact on. Now, we haven't gotten to the stage where we're doing kind of that uplift analysis, where we're kind of differential response analysis, depending on what you want to call it. Eventually, we want to get to that because obviously, in any subscription business, like there's a quote, I may butcher it, but Woody Hayes, an old football coach at Ohio State, said, when you throw the ball downfield, when you pass the ball, 3 things can happen and 2 of them are bad. With a subscription business, sometimes reaching out to somebody, it may not generate a good outcome. You may convince them that, oh, I haven't watched in a while. Maybe I'll leave and then come back later for that show that I'm really interested in. So we need to be really targeted and really testing all the various tactics and approaches to connect people with the content that we think is going to resonate with them. But there's no free lunch. It's not a freebie to just send an email and have it be ignored or whatever, because you could always cause, there's the trade-off, the good and the bad outcomes.
Thank you.
Hello. Thank you for the talk. It's really great. I have one question about, you briefly mentioned about CRM earlier on your master reviews table. So I'm just wondering, in terms of like, a lot of time, like things like CRM attribution, they're like a third-party service that the company does not operate themselves. So I'm just wondering, like, do you have any like difficulty, trouble, like integrating that data to your own system, since like there are external data from a different third-party systems? So
you're talking about, I may not have heard it completely, ingesting the CRM data?
CRM or like maybe attributions data, anything that's like coming from a third party instead of you collecting it yourself.
Yeah, I mean, there's always going to be challenges with third-party data. In this case, some of the more interesting data points from a CRM perspective are things like opt-ins and opt-outs, or even tracking that somebody has been receiving emails but has ignored them for a while, versus somebody who's opening everything that we send to them and clicking on them and then viewing the content we're promoting. So there's a lot of like rich behavioral set of features that we can create based on the CRM interactions. We haven't created those yet because we've had some, I'd say, lower hanging fruit, but it's on our list of things to cultivate. But there will be challenges every time we try to incorporate third party.
This one will be the last question.
Okay.
And I'm sorry if I missed it during the presentation. What's the underlying storage technology for the master viewer record? Like, what is Tableau querying? Is that the data warehouse, or what is that technology?
Yeah. So technically, we're really just creating a table of data that's getting ingested into Tableau server. It'll be like literally like a CSV file at that point. It's still quite large. But it'll be something along those lines, CSV or tab delimited or pipe delimited.
Got it. So they're basically just interacting with like the extracts that are in Tableau server, is that?
I don't know that we have dug in. So we don't control the Tableau server instance. So we work with CBS engineers, our parent company, CBS, and they kind of handle that portion. So we basically just sort of provide the location in S3 of our master viewers table. They do a copy and an ingest using some process that they prefer for Tableau server.
Got it. So your result set is just a CSV file that gets uploaded.
Exactly. Yeah, we're fundamentally creating like a table, like a CSV, a single CSV file. Or actually, I guess technically it may be split.
Yeah, it's partitioned.
Technically it's partitioned. So.
Okay. Cool. Thank you.
Cool. Awesome. Cool. Thank you.